plastic. So dicyclopentadiene is what shortly known as DCPD, which requires a cooling in the mold. If reinforcement agents, commonly a glass fiber or mica, are added to the base material, then the process is called reinforced reaction injection molding. Subset of RIM is a structural reaction injection molding, which uses a fiber mesh for a reinforcing agent. The fiber mesh is arranged in a mold and polymer mixture is injected into the mold. DCPD RIM can produce a strong, flexible, lightweight parts that are easily painted. The bicomponent mixture injected into the mold has which has got a much lower viscosity than the molten thermoplastic polymers. Therefore, large, lightweight and thin-walled items can be successfully produced with the DCPD RIM process. The common items made with the DCPD RIM includes automotive bumpers, air spoilers, fenders, accommodating highly dimensional parts with a range of wall thickness. Excellent molded surface suitable for a Class A painted finish, good adhesion, lightweight, impact resistant characteristic of this DCPD RIM process part, and excellent stiffness and physical properties, and it can also be machined. The finished parts will have a high impact strength and toughness, and this process is mostly suitable for medium to high range of parts, and the tooling is mostly metal and sometimes even composite, and the part range can be between 200 to 10,000 parts per year. And the picture here represents how reaction injection molding is. So basically there is a mold and there will be part A and part B which will be injected into the mold, and because of the heat circulation part gets solidified. So let us look at the direct long fiber thermoplastic. Although it is kind of categorized in thermoset, this may not be a fully thermoset process. This could even be a thermoplastic. This is a relatively newer technology. Basically, thermoplastic material is directly compounded with a long fiberglass and then molded in one operation. Basically, the fiberglasses are cut between shorter to a medium length and added into a compound and then molded in a closed mold environment. And this is normally used for medium range of volume application ranging from 10,000 to 40-50,000 parts a year. The polypropylene is the most common thermoplastic used in this process, but even PTE and PBTs are also being used. The picture represents the process, how it works. Basically, there will be fiber which will be cut and mixed with the resin and additives, and the compound is prepared, and then the compound is shifted to a press where the closed mold process will take place. Now let us look at pultrusion. Pultrusion is a continuous process of manufacturing a composite material with a free-defined cross-section. In other words, pultrusion can be compared with the aluminum extrusion or aluminum presses. as exposed to extrusion, which pushes the material. Pultrusion works by pulling the material. This process has experienced a significant improvement and nowadays one of the most cost efficient methods of producing composite material having consistent cross-sectional profiles. This continuous processing technique used for molding composite offers formation of high quality engineering industrial products which have a close dimensional requirement. Pultrusion process is a simple process which allows for the fabrication of continuous length composite to the desired close dimensional cross sections. The picture represents how the pultrusion process works. You can see the fiber getting processed through rollers and feeded into the resin bath where it gets wet, and there will be a resin control unit. Then it will be passed through a different profile and heating chambers than pullers. So once they pass through this area, the profile is created, then it is pulled, then it is cut to a required sizes, and then part is used. That brings us to the end of thermoset plastic. Now let us look at classification in thermoplastics based on the processing methods. Extrusion, calendering, film blowing, injection molding, blow molding, rotational molding, compression molding, or also known as transfer molding, an advanced version of compression molding, or high production process of compression molding, plastic casting, and thermoforming. And these are all the main processes under thermoplastic. So we will go each process and see them what each process mean to us. Extrusion. This is same like pultrusion process what we have seen in thermoset plastic in some way, but altogether a different way of manufacturing. This is a continuous process is used to produce film, sheets, profiles, tubes and pipes and plastic materials. Plastic material as a granule or a pellets or a powder is first loaded into a hopper. So this can be called as a hopper here in the picture. And then feeded into a long heated chamber through which it moves, and then action of continuously revolving screw. This is the area where the screws can be seen and the heater zones. The chamber is a cylindrical and referred as an extruder. The extruder can have one or two revolving screws. The plastic is melted by a mechanical work of a screw and the heat from the extruder wall. At the end of heated chamber, the molten plastic is forced out through a small opening called dies from the shape of a finished product. As the plastic is extruded from the die, it is fed into a conveyor belt for cooling, onto a roller for cooling, or by immersion into a water for cooling. Example of extruded products includes lawn edging pipe, films, coated papers, insulation on electrical wires, plastic lumbers, window trims. Thermoplastics are processed by continuous extrusion. Now let us look at calendering process. This is also a continuous process, is an extension of film extrusion. There is still warm extruded is chilled on a polished cold rolled sheet from 0.1 mm to 12 mm thick. The thickness is well maintained and surface made smooth by polished rollers. Calendaring is used for a high output and the ability to deal with a low melt strength. Heavy polyurethane films used for construction of vapor and liquid barriers are calendared. High volume PVC films are typically made using calender process. Now let us look at film blowing process. This is also a continuous process. In this process, extruder vertically extrudes or blows the molten polymer in an upward direction like a fountain. A bubble of air is maintained that stretches the plastic axially and radially into a tube many times the diameter of a ring from where it is getting extruded The diameter of the tube depends on the plastic being processed and processing condition. The tube then cooled by air is nipped and wounded continuously as a flattened tube. The tube can be processed to form a sealable bag or slit and form the film. And in this process, the thickness of the material can be as low as 7 microns to 120 microns. And multiple layers of different resins can be used to make the tubes. This is how the film blowing process works. So let us look at injection molding now, which is widely used and known process for us in plastic. This process can produce intricate three-dimensional parts of a high quality and great reproducibility. It is predominantly used for thermoplastic, but sometimes thermoset and elastomers are also processed by injection molding nowadays. In injection molding, plastic material is fed into hopper, which feed into an extruder. An extruder screw pushes the plastic through the heating chamber in which the material is then melted. At the end of extruder, the molten plastic is forced at a high pressure into a closed cold mold. The high pressure is then needed to be sure the mold is completely filled. Once the plastic is cools to solid, the mold opens and the finished product is evacuated. This process is used to make such items as yogurt containers, bottle caps, toys, fittings, lawn chairs. Special catalysts can be added to create thermoset plastic products during the process, such as cured silicon rubber parts. Injection molding is discontinuous process as parts are formed in cured before being determined by how mold and must be cooled in remote. The economics are many parts can be made per cycle. Based on the mold construction, many parts can be made in one cycle, and that's the possibility. Now let us look at blow molding process. Blow molding is a process used in conjunction with extrusion or injection molding. In one form, extrusion or blow molding, the die forms a continuous semi-molten tube of a thermoplastic material. A chilled mold is clamped around the tube and compressed air is then blown into the tube to conform the tube to the interior of the mold. and to solidify the stretched tube. Overall goal is to produce a uniform melt from form into a tube with a desired cross section and blow it into an exact shape of a product. This process is used to manufacture hollow plastic products, and its principal advantage is its ability to produce a hollow shapes without having to joint two or more separately injection molded parts. This method is used to make commercial drums and milk bottles. Molding technique is to injection mold a shape called free form, and then to heat the item to such an another blow, and intermediately if you form the blow and heat the softened plastic into a final shape in a chilled mold. This process to make a soft drink, most of the soft drink bottles are made from this process. Now let us look at rotational molding. Rotational molding consists of a mold mounted on a machine capable of rotating on a two-axis simultaneously. Solid or a liquid resin is placed within the mold and heat is applied. Rotation distributes the plastic into a uniform coating on inside of the mold. Then the mold is cooled until the plastic part cools and hardens. This process is used to make a hollow configuration common rotation molded products, including shipping drums, storage tanks, and some consumer furnitures and toys. Let us now look at compression molding. This compression molding is more or less similar like what has been discussed as compression molding in thermoset plastic. Same like in thermoset plastic, in this process as well, a pre-prepared fixed volume of plastic is placed into a mold cavity, and then the second mold or a plug is applied and squeeze the plastic into a desired shape. The plastic can be semi-cured thermoset, such as an automobile tires, or a thermoplastic or a mat of a thermoset resin, and long glass fibers such as boat hulls. Compression molding can be automated. Transfer molding process can also be utilized to expedite the production process or volume output. The formation of plywood-oriented stand board using a thermoset adhesive is a variant of compression molding. The wood veneer stands are coated with the catalyzed thermoset phenol, form the resin and compressed, then heated to cure thermoset plastic to form into a rigid non-melting adhesive. This is how most compression molding parts are manufactured. Now let us look at plastic casting. Although it look a bit different that plastic casting is existing. This is a process which is a low pressure casting, often just pouring an addition of a liquid state plastic resin into a mold. Catalyzed thermoset plastic can be formed into a integrate shapes by casting. Molten polymer is poured into the mold, and then the part is created. Now let us look at thermoforming. Film sheet of a thermoplastic are heated to soften the film or the sheet. Then the softened film is pulled by a vacuum or pushed by a pressure to conform to a mold or pressed with a plug into a mold. Parts are then thermoformed either from a cut piece or a thick sheet, and sheet thickness can be as low as 1.5 mm of a roll of a sheet or a pre-cut sheet. The finished parts are cut from the sheet and scrap of the sheet material recycled for manufacturing the newer sheet. The process can be automated for high volume production, and clamshell food containers can also be simply hand labor process can be made from individual crafted items. The picture above shows the typical process how a thermoforming is done. This table gives us an overview how each of these processes can give us different areas, like what kind of investment each of these processes demand and what kind of production rate we can expect from each of these processes, and at what scale of production these processes become economical. Like extrusion process, the investment is medium to low in terms of tooling requirement. The rate of production is very high to high, and scale is very high. So to achieve economy in this process, the production range has to be very high. The injection molding process, the investment in the tooling is very high. The rate of production is also very high, and scale of economy is also very high. That means injection molding process is more suitable for a high volume production. Rotation molding, where investment on the tooling is medium, the rate of production is also a medium, and the scale of economy is also a medium. So medium range of production parts can make economical sense for rotational molding process. And it is more or less same with the blow molding. The investment in the tooling are medium, and production rate is bit between medium to high, and scale economy is also high. That means one, for economical production, the high volume production is what this process demands. Compression molding, the tooling investment is between medium to high, and rate of production is around medium, and scale of economy is between medium and high. In terms of transfer molding, which is more atomized process of compression molding, the tooling investment is high because we need to employ multiple tools. The production rate remains medium, and scale of economy will be on high volume production. Thermoforming, on the other hand, the investment on the tooling is medium to low or low to medium, and rate of production is also a low to medium, and scale of economy is between medium to high. The casting process, the plastic casting process, the investment in tools is low to medium, and rate of production is also between low and medium, and scale of economy is it is quite okay to have low volume production done. The centrifugal casting, it is also more like rotational molding with additional centrifugal force is being applied to circulate the material to stick to the walls. The investment in that case is between medium to high, and rate of production is quite okay between low to medium range, and the scale of economy is fine in terms of low to medium production volumes. Let us look at elastomers. So we have now went through more detailed view of thermoset plastic, thermoplastic, and now let us look at elastomers. Elastomers commonly known for us as rubber. An elastomer is a polymer with a property of elasticity. In other words, it's a polymer or a rubber that deforms under stress and returns to its original shape when the stress is removed. The term is contraction of a word elastic polymer. There are many types of elastomers, most of which are rubber. The term elastomer is therefore often used interchangeably with the term rubber. Other elastomers which melt when heated are classified as thermoplastic rubbers. Both natural and synthetic are widely used for manufacture of tires, tubes, hoses, belts, mats, gloves, toys, balloons, rubber bands, erasers, adhesives. Thermoplastic elastomers are used in manufacturing process such as even by injection molding process. Thermoplastic polyurethanes are also used for various applications including the production of foam, seats, foam used in seats, seals, gaskets and carpets. These are all kind of examples of elastomers. So let us look at elastomers more in detail. Unsaturated rubber that can be cured by a sulfur vulcanization. These are all the products or end results or the name of rubbers we commonly known with this process. The natural rubbers, synthetic rubbers, butylene rubbers, homogeneous butyl rubbers, polybutadiene, commonly known as BR, synthetic rubber, which is commonly known to us as SBRs, nitrile rubbers, which we know them as NBRs, and hydrogenated rubbers, which we know are nitrile rubbers, which we know as HNBR, and CR, then we know as neoprene, bioprene, etc. So these are all different elastomers, which are are rubbers which are manufactured by sulfur vulcanizing process. Then let us look at some of the saturated rubber that cannot be cured by sulfur vulcanizing, like we have EPDM, then EPDM or EPM, then ECO, ACM, ABR, SI silicon rubber, then fluorosilicon rubber, fluoroelastomer. These are all the different type of rubbers which cannot be cured by sulfur vulcanization. So various type of elastomers what we see are thermoplastic elastomer, which we know as TPE, thermoplastic vulcanized, that is something we talk as TPV, then thermoplastic polyurethane, which we also call in short as TPU, then thermoplastic olefins, which we call them as TPOs. So different activities in polymer process. Basically, the process which carries from the raw material into a finished product. They go through a set of processes called as mixing, textile treatment, calendering, spreading, extrusion, mold curing, rubber mold bonding, vulcanization, latex process, polyurethane rubber. These are all the different processes which take the raw material into a final elastomer, which we know them as parts or product which we use them. So let us look at different elastomers and their processes. So thermoplastic elastomers, we use injection molding, extrusion, and some other technique of calendering to manufacture thermoplastic elastomer into a final product. Let us look at different processes and what they mean, and different ingredients get into these elastomers. Accelerators. These are all the compounding material that facilitates and speeds up the vulcanization process of these elastomers or rubbers. The accelerator consists of complex organic compounds. Activators. These are all the compounding materials which facilitate vulcanization reactions. Antidegradients. The compounding material which protects against oxidization, antioxidants, antijonants, and waxes. Crystallization, a phenomena which takes place in a certain type of elastomer which with highly regular molecular at a low temperature. The molecular chain arrange themselves closely together, the material hardens. When the temperature is increased, the material regains its previous properties. This applies primarily to the natural rubber and chlorofluorine rubbers. Curing agents. The compounding materials which form a cross-linking during the vulcanization, most common are sulfur and peroxides, but also resins and metal oxides are used for this this process as a curing agents. Fillers. Fillers are basically compounding material which dilutes the polymer. There are normally two types of fillers. One is reinforcing and another one is non-reinforcing. So reinforcing polymers or fillers increases the strength of the elastomer or rubber part of the product we get. They consist of a material with a small size particles as reinforcing fillers. The common fillers used in rubber are black carbon or silica. The non-reinforcing fillers are pure dilutants which reduces the basically used for reducing the cost of the product and also add impurities to the to the part and work with the mechanical properties of the end part or product.